Hi there, this is lesson 7.6, and in this lesson we're going to be doing some more word problems, but this time finding angles instead of finding sides. So we can jump right into examples this time because we've already gone through kind of the process for doing these. So go ahead and pause if you need to get this written down. What it says is a 20-foot ladder leans against a building. If the base of the ladder is 5 feet from the base of the building, what is the angle between the building and the ladder? So again, I always say just kind of go back through your problem and make sure that you are picking out all of the important parts. So we have this 20-foot ladder, and that 20-foot ladder is leaning against a building. So it's kind of diagonal since it says it leans. The base of the ladder is 5 feet from the base of the building. And then what is the angle between that building and that ladder? Okay, so I would just start by kind of drawing my ladder. So I know that I have this ladder that's leaning. Here's my ladder. And it's leaning against a building. Well, buildings are usually, if they're built correctly, they are usually vertical. So there's ladder, and there is building. And now you can see that we already kind of have our right triangle going. So I'm just going to complete it like so. And let's keep reading here. It says the base of the ladder. So here's the base of the ladder. Base means bottom. Is 5 feet from the base of the building. So base of the building is here. Base of the ladder is here. That distance is 5 feet. Okay. Our ladder is 20 feet long. So I'm going to add that right here. And the question then is, what is the angle between the building and the ladder? That's our question. That's what we're looking for. So we got to find our building right here. We got to find our ladder right here. And this is the angle we're looking for. That's where our X is. That building, or sorry, that angle on top between the ladder and the building. Okay. So we don't have any information about the building. We don't know how tall the building is, so we can kind of ignore that for now. So what we do have is we have the hypotenuse given to us. We have the opposite side given to us. So if we remember our SOHCAHTOA, sine is the one that has O and H, opposite and hypotenuse. So we're going to say sine of x, we don't know yet, is equal to our opposite side, which is 5, over our hypotenuse, excuse me, which is 20. Okay? And then the angle problems, they're actually easier than the side problems because all we have to do at that point is take the inverse of both sides. That will allow us to get rid of sine so that x is by itself. And we are going to just round to the nearest degree. So we got to get on Desmos or find a calculator and type in inverse sine of 5/20. So I'm just going to double check that I'm in degrees. I am. I'm going to open up this little calculator thing, hit functions, inverse sine, 5 divided by 20. And we get 14.47. Again, we're going to go to the nearest degree. So since it's 14.4, we're going to keep it at 14. So approximately 14 degrees. And if we want to just kind of throw that in our diagram, that would be great. All right, and then just one more problem here. It says a plane takes off and needs to clear a 100-foot building that is 1,000 feet away. At what angle of elevation must the plane take off at to clear the building? So pretty important stuff here. We don't want our plane crashing into our building, so we need to make sure that we have a high enough angle to clear the building, okay? So plane takes off. I'm just going to kind of visualize that. Here's a plane taking off. Okay, started at the ground and it takes off diagonally. Okay, it needs to clear a 100-foot building. So let's put in a building that is 100 feet. That's our building. Okay, now you can see our right triangle is formed. And it says that that 100-foot building is 1,000 feet away. So here's where our plane took off. Here's where the building is located. That distance is 1,000 feet. Okay, now the question is, what angle must this be? Put a degree sign there. What angle must that plane take off at so that we don't crash into the building? Okay, so label your sides. Looks like we have the opposite side from that angle we're looking for. We also have the adjacent side. We don't have the hypotenuse. We don't care about the hypotenuse. We're going to use tangent. Tangent is the only one that doesn't use the hypotenuse. And tangent is opposite over adjacent. So tangent of this unknown angle is equal to 100 over 1,000. Okay, from there, I think pretty simple. Take the inverse tangent of both sides, and that will tell us that x is approximately, maybe we don't want to be approximate this time. Maybe we want to be perfect. I'm going to go with perfection so we don't hit the building. Okay, so inverse tangent of 100 divided by 1,000, and we get 5.7. Okay, so anything under 5.7 would be a problem. We would crash. We have to be going at least 5.7 degrees. So I didn't really talk about how I want this answered. One thing we could do is we could say, okay, x has to be, let's just go to the nearest degree. X has to be at 6 degrees, because that would be the nearest degree. We definitely wouldn't want to go down to 5. That'd be bad. We'd crash. Or we could say this. We could say x has to be at least 5.7 degrees. Okay, or x has to be at least 6 degrees if we were rounding to the nearest whole number. So again, I didn't really give directions here. So just if a problem like that comes about, just think about what would make the most sense, or how perfect are we trying to be. Obviously anything over 6 degrees would be good. We wouldn't crash into our building, so that would be good. All right, so go ahead and practice. Make sure you're drawing pretty diagrams that make sense, and doing a good job with this lesson. Good luck.